So just a quick framework. Something to think about. You could have this in your box. I always think about it for my own startups. For example, I many times looked at it this way. So, for example, if you take classical computing, I mean, maybe CPU, GPU, TPU. I mean, we all know they are solving real needs, real problems, right? Many companies use GPUs, TPUs, and they are very effective at their job. So if you look at, so for example, the satisfaction, let's say with GPUs in the marketplace is very high. And the importance of the need, the problems they are trying to solve is very high. So the GPUs, let's say, for example, are in the right-hand quadrant, right? The importance of the need for the customers for GPUs is very high, and the satisfaction with them right now is also very high. So in a way, they are in the top right corner. Now, let's say you want to start a quantum computing company, and you want to, would you ever go into the right quadrant? You know, there are already successful players, and the customer seems happy, right? So you wouldn't necessarily play in the same space. So if you look at quantum computing specifically, I mean, I don't think the power of the quantum computers is fully realized if you just think of it as another way to get things done faster, right? If you just think of it in the continuum of CPU, GPU, TPU, and maybe now QPU, then I think that's not the whole story. You will run into a lot of competition. But if you look at the whole quantum technology from a perspective of can we solve different problems that the classical computers cannot handle because of their architecture, then I think the whole game changes. So for example, if you look at optimization problems, right? A lot of companies want to address those, right? They all have optimization problems, let's say in the chemical industry or the materials industry. So the importance of the need to optimize certain things is very high. But perhaps the classical computers are not as well suited. So the satisfaction with them, let's say currently, is low on the, right? So if you are now coming up with a quantum computer and you can address those class of problems in a better way, you land up in the top left corner, right? So that's the way for you to move away from the competition and figure out how. So this is where I think quantum computing can do wonders. Okay? There are definitely areas where these quantum computers can solve certain things and a new class of problems better than the classical computers, and that's where I think there is a lot of opportunity in the if you think about this framework in the top left quadrant, right? If you're coming up something and using quantum computer for just solving classical the problems that the classical computers do, then you are getting into head-on competition, and there may not be that much gainful, right? So again, you need to constantly think about what opportunities should I go after, because you are betting your whole company, all your resources around that. So I have a question for you. So all these different cases, examples that we talked about, I mentioned those in the light of emphasizing how important feasibility is. For example, technical feasibility, right? How important desirability is. Do the customers want it? Now, let's say you have a startup and you have done a wonderful job where your solution, your technology is feasible. You have understood the desire in the marketplace. Is that enough to be successful,